The first game we're going to make here on the course is a simple tennis game, stylized to look somewhat like the classic arcade game Pong. We're going to have the ability for us to play as a single player game facing against a computer controlled opponent, or to play a multiplayer game with anyone else who wants to play with us along the way. So I'm just going to show here our single player game will feature us controlling this paddle on the left here, trying to bounce the ball back and forward and get it past the other object, or the other paddle on the other side. And every time the ball goes by, we'll get a score. And our race is to get as much score as possible, and when you reach a certain score, the game is complete. So, for example, if I just lose to this guy a couple of times, player 2 wins. Nice and simple like that. I'm going to go back to the main menu. In multiplayer here, we'll have it so that our players control both the left paddle and the right paddle here, using our keyboard to move around within the world. And again, it's just whoever gets the most score wins the game. So if I just let the red one win, I'm not very good at letting someone win apparently, we'll just let the other one win. As you can see, every time the ball loses, it flicks back to the other side, and you lose the game by losing a set amount of points. So now that we've seen the game in action, let's go ahead and start building it. Okay, so we're going to start out by creating a new project in Unity. To start up a game, we obviously need to decide where our game is going to be saved. I have that already set up in our location here. We need to give the game itself a title, or the project file a title, which we'll just call it Tennis, keep it nice and simple. And we need to make sure that we make it a 2D game, because this isn't a 3D game that we're working within. Although you could still just as well use 3D objects within our 2D project. We're just setting it up in 2D by default because we know that we're going to be working as a 2D game, and it's more straightforward, and basically it just sets up Unity with a bunch of defaults for our project. So now that we have those settings all set up, all we have to do is hit create project, and it'll start setting up our game and opening up Unity for us. So once Unity is all loaded, we'll see ourselves here in the default view. And now we can actually start on our project. So before we start the project, I'm going to give a quick little overview of the basic layout of what we see here in Unity. So if you're already familiar with the layout of Unity, you can skip on to the next video. But for those who haven't encountered Unity before, we've got a basic kind of screen set up here, divided up into windows, and we'll just go through what each window is. So starting off down here, we have the project folder. So the project folder will be where we store all our assets in the game. So say for example here, we start off by default in the assets folder, so we can create extra folders here. We can create folders, scripts, materials, sprites, a variety of different things, and basically this is where all our objects will be organized within the game. So we'll see here beside the project we have console. Console is basically any messages that Unity gives to us. So if there's any errors or anything like that, they'll appear here in the console, and if we have any problems with whatever scripts we're writing, they'll appear here in the console, and we'll know how to fix them then. Or at least we'll know that we have an error and to look at them and how we can fix them. So those are our basic. So some of our basics down here. Up here on the left we have our hierarchy, and this will be any objects that are currently in use within our active game. So the way we can see what's active in the game is what's in our scene view here. So this is our main kind of view that we use to interact with the world and what we're doing within it. So if I was to, for example, in here, if I were to go up to the top and go to game object and create a new cube here, so it'll pop a cube into the world, and you'll see over here in our hierarchy on the left, we now have a cube listed down here, and we also have the main camera just as an object within the world, and as something that can see things within our world. So we can see here our main camera is represented by this object here, and then we have our cube represented obviously as a cube here, although because we've set our project up in 2D, it only appears as a 2D square. Now, if we wanted to switch to having our scene view actually be in 3D, we can hit this 2D button up here, which you can see is already highlighted, so that means it's already active. So we can click on that and it will go to a 3D kind of cube view, but we're not really messing around with that for the moment. We're going to go back to 2D. We're keeping it nice and simple and sticking with the 2D components of Unity. Now, if we wanted to manipulate these objects within the world, we have a bunch of little buttons up here that allow us to do that. And we'll go through them from left to right. So we have this little hand symbol, and there's a shortcut to activate that. So we can just hit Q on that if we want to, like that, and it would activate. Our hand symbol just allows us to move around within the scene view. Another way to do that is if, so say for example I was on a different object, if I just right click, I can click and drag around the scene view like that. So that's what our hand tool does. Then we have this directional tool, which is for moving objects around the world. So if I have that selected and I have my cube selected, we can click and drag that around within the world like that. We can then look at the next object, which is our rotate tool. So our rotate rotates around 3 different axes, which are the X, Y, and Z axis. Although because we're in 2D, we can only at the moment see X and Y. So if I was to grab this green line here, I can rotate that object around like that. If I was to grab the red line, I can move it and rotate it like that. And you can see when we rotate, we can now see the Z-axis line. So if I were to grab that and rotate it, now we can see our object is it's looking more like a 3D object, even though we're in a 2D view. I'll just reset this back. So that's our rotate tool. Then beside that we have the scale tool. So our scale tool can be used to, if we click on the white square in the middle, you can make our object bigger in all dimensions, or we can click and drag it in just one axis, or click and drag it up and down like that. So we can adjust the size of our object to whatever kind of size we want it to be. And finally we have the last button on the array of little buttons that we have here, which allows us to freely kind of manipulate whatever our object is. So it kind of works with it's similar to our scale tool. We can click and drag it around, but we can manipulate by its corners. We can also click on it and drag it around within the world. So it's a very handy tool to be able to use in that way. So that's the basics of how we manipulate our tool, our objects within the world. So this is basically everything we'll want to do with our scene view. We can then look here. We have this game tab. So if we switch over to that, this is what our game will currently look like when it's running. So when we're on the game view, we can't interact with anything here at all. This is just replicating what we can see with it when the game is running. So if I switch back to our scene view, if I was to move the cube over here, we can see it's moved in our game view. And if I just zoom out, if you use the scroll wheel on your mouse, it'll zoom in and out of our scene view here. So if we were to grab the camera now and switch over to our move tool, and we can move that around, you'll get a preview of what the game view will actually show. So if we're looking in the bottom right corner here, we get this camera preview, and that directly reflects, if we switch over to the game view, exactly what is seen within our game view. So we can see if we move the camera, say up here, now our box is down in the bottom left. So as I said, the most important thing to remember is in our game view that we can't actually interact with that in any way as we're editing our game. And if we switch back to our scene view here, when we hit the play button up here, so the play button will make our system run as if the game itself is actually running. So if I hit play, it can sometimes take a couple of seconds to activate. And then we see when these buttons go blue here, that means that our game is now active. And it switches automatically over to the game view. So whatever game we have running, obviously it'll be a bit more active than just having a box on the screen. But if we switch back to scene view, while the game is running, we can make any changes we want here. But there's one important thing to remember, and that is that any changes you make while the game is running won't be applied when the game is then stopped. So say for example, I'm going to move this cube here. I'm going to move it down to the bottom left. So in our game view, now our cube is down at the bottom left there. But if we stop the game running by pressing the play button again, when we switch back to the scene, we can see our cube goes back to where it originally was when we started running the game. So it's important to remember that any changes you make while your game is running won't be applied when you stop the game running that time. It's just one of those little things that it's important to remember, but you'll likely incur it and you'll forget it as you go. It's just one of those things you'll pick up more and more as you do things within the game. So just before we move on any further, I'm going to hit the play button again here. We see we have these 2 different buttons here. All that they do is pause the game. So if we had any motion going on here, we would see that the game would be paused. I'm actually just going to very quickly give this cube some gravity. I'm just going to give it... You don't need to worry too much about what we're doing here for the moment, but just as an example, I'm going to hit play, and we'll see our cube fall like that. So if I hit the pause button before we hit play, what'll happen is it'll just pause our game in action. So when we hit play, it doesn't automatically, because we paused it, it doesn't automatically switch over to our game view. So if I now unpause it, we'll see it fall. I can pause again. And then finally we have our third button here, which is just makes it move on by 1 frame. So we can see it just moves on to the next logical bit of movement that happens. And those are our 3 buttons up here in action. So finally, we have over here on the right the inspector view. And the inspector view shows us details about whatever object we have activated within our game. So I'm just going to switch back over to our scene view. So on our cube, for example, here in our inspector, the first thing we have is transform. And transform dictates where everything is within the game. So when we move our object around, you can see our position in the transform changes. When we rotate it, you can see that our rotation changes depending on which axis we move, like that. And then when we scale it, you can see our scale here gets moved up and down depending on what we do. So transform is one of the most basic elements that you'll see in the inspector, and you'll see it for every object that exists within our game. So if I was to change the camera, you'll see the camera also has a transform component as part of it in the inspector. It's something that any object within Unity will have a transform, because we'll need to know where any object can be within the world at any particular time. So because this is a cube also, it has a cube mesh applied to it. It has a box collider because it needs to be a physical object, so it has a box applied to it. It has a mesh render so that we can see it, and then I give it a rigid body, which makes it have some gravity. Again, you don't need to worry about any of these components just yet. They're just things that exist. But just as another example, when we switch over to our camera, then it still has the transform component applied to it, but it also has the default camera script applied, and has a couple of other default things down here as well. So that's the only differences between them, but it's just important to note that when you want to see any kind of information about any object within Unity, you look over here at the inspector. Those are the basic kind of elements of our windows here. There's nothing else really to them. So the next thing we're going to do is look at making our actual project that we're going to work on next all set up nicely. Okay, so the first thing we want to do before we go making anything of our project itself, we're going to lay out our project and set everything up to make it nice and easy for us as we go through our game. So one of the first things we want to do is, if we switch over to our game view here, we've got this kind of default blue background, which isn't very which isn't what we want basically in our game. We want to have a nice black background so that our simple kind of sprites stand out from it. So what we'll do is go to our main camera here, and we're going to change the background color of the camera. We're just going to click on this little circle here and drag it down to the bottom left corner so that it just makes it all completely black in the background. The next thing we want to do is make sure on our display over here we have free aspect, and free aspect refers to the amount of space that our people can see on our screen. So if I click on free aspect here, we're going to change this to be 16:9, and that's the kind of default resolution of like HD screens and stuff like that. And the reason we do this is so that we know that no matter who is looking at our game, we want them to be in the 16:9 ratio, so that where we lay stuff out in our screen, everybody will be forced to see the same exact thing. So say for example, if we were to put the walls that the ball is going to bounce off of, if we were to put them say from here to here on our 16:9 view, that would be perfectly fine. But if someone had a really widescreen monitor, what would happen is they'd have a whole load of black space over here that wasn't really doing anything, and that's not what we want. So what will happen is we want to force it to be 16:9 so that no matter what, the person won't be able to see this area off to the left and the right. And we'll apply that when we're building the game. So we want to make sure that when we're actually making the game, we want to work within the constraints of the 16:9 ratio. So that's why we set it up here in our game view to be set up just like that. And when we set that, if we go back to our scene view here, what happens is our camera will now reflect this setup that we have. So the box around the edges of the camera here will be now set to be 16:9. And just for as an example of that, if I go here and set this to be 4:3, which is more of a square kind of look almost, you can see that our camera again gets shrinked in like that. So let's switch this back to 16:9. And you see it stretches out to, so we know now that this is the entire area that we want to build our game within, because we don't want our camera moving around. It's a simple kind of Pong style game, so we don't want the camera jumping around. We want objects within the world to be the only things moving. Okay, so that's our camera setup. The next thing we want to do is set up some folders down here for laying everything out as we go through. So I'm going to create a folder like that. I'm going to call this folder, we'll call this one the art folder. So we're going to put a little bit of an art file in there. I'm going to make another folder here by going to assets, create folder. There's just a couple of different ways to do the exact same thing. We're going to call this one materials because we're going to put some various materials in there. We're going to create another folder that we'll call prefabs. I'll explain all these folders obviously as we go through the actual making of the game itself, but it's just handy to have them already set up for us in our game before we do anything. We want to have a scenes folder, and then finally we want to have a scripts folder. So perfect, those are those basic little things set up. The next thing we want to do is go into our art folder here, and we're going to bring in a sprite that we're going to use for basically all the objects within our world. So in the downloads attached to this first video, we'll see that there's a sprite here called white sprite. So I'm just going to click on that and drag that into the art folder like that, and now we have this sprite within the world, so we know we can actually use this in our game. And just for example, we can just click on this and drag it into the world, and now we have this little white box within the world like that. I don't want to actually have that there yet though, so I'm going to delete that. Then we're going to pop back up to our assets folder here, and the next thing we're going to do, now that we have all these files set up and we have our basic kind of game set up, what we want to do is make sure that we save this scene before we do anything else, so that we know as we add things in, we can just save it as we go and we don't have to worry about losing all our progress. So what we're going to do is go to File, Save Scenes, and then we're going to go into our scenes folder that we just created, and we're just going to call this level 1, and we'll save that. Okay, so there we go. Now we've got our basic scene set up, so let's start adding some actual structure to our game, and we're going to look at adding some walls. Okay, so to start making our game actually look like something real, we're going to add some walls at the top and the bottom for our eventual ball to bounce against the wall. So we're going to go into our art folder, we're going to grab this white sprite here, and then over in the hierarchy on the left, I'm going to rename this. So I'm just going to click on it and rename it to be wall top, because we're going to put this up on the very top up here. What we want is for this object to be actually in the exact center of our view. So on the x-axis here on our transform, I'm going to set the position to be 0, and we're going to click and drag it and move it up so it's just up the top up here. I'm just going to zoom in on this a little bit so we can see that it's an actual box. And then the next thing we want to do, this tiny little box, if we switch over to the game view, that's all we have up here. That's not going to make a very good wall, so we're going to make it stretched out to be the full width of our screen. So to do that, we're going to go back to our scene view, we're going to zoom out a little bit, and then we're going to switch over to our scale tool. We're going to click on the red axis, and we're going to click and drag that out and keep dragging it over to the right. You'll see if you hold the drag button down, our mouse goes off the screen to the right and wraps around over to the left to allow us to just keep dragging as we go. And we're going to drag that out so it's kind of almost to the edges, out like that. And then we can see, switch over to the game view, now we have this wall up the very top. I might actually just move this up a tiny bit more so it's a bit closer to the top. There, like that. We can see it's at 4.7, that's fine. The next thing we want to do is make this a real thing within our world. And by that I mean a thing that our other objects can physically interact with. At the moment, all that we've done is drag this little bit of art into the world and stretch it out. If we were to have other objects within the world that wanted to bounce against us, they wouldn't know anything about how to bounce against us, because all it is just a drawing within the world. So what we'll do is go to add component down here, and what we'll type into the search bar at the very top is, we'll start typing box, because what we want is a box collider 2D. So I'm going to click on this here and it'll apply it to the object. And what that does, if we zoom into the object, it's a little bit hard to see because of our white object, so it might not come out on this video very well, but you should be able to see in your own Unity view there's a little tiny green box around the edges of our object. And because we scaled the object itself and made it as wide as it could possibly be, what happens is our box collider will fit to that exactly. So it'll always try to fit to the very edges of any kind of drawn object. So even if you have, say, a circle drawing popping into your game, if you apply a box collider to it, it'll still just apply a box to the very edges of that circle. So just as an example of the green box itself, I'm just going to grab this x-axis here. So if I click on the x here and drag it to the right, what that does is it drags the box out. So you can see now there's our little green box. It's been dragged out a little bit further. If I drag it some more, you can see it extend out. Obviously we don't want it to go any further than what our wall actually is, so I'm going to set this back to be 0.32, which was the default. So now we have this first wall set up. We want to do a similar thing for our bottom wall, but rather than having to go and drag in the sprite and make it all over again, what we can do, I didn't mean to move that, what we can do is hit Control and D when we're in the scene view and we have an object activated. If we hit Control and D, what that does over here, you can see that created a clone of the object. So now what I can do is just click and drag that down the bottom here, like that. So we had our first one was at 4.7 on the y-axis we saw up there. So this one is now going down at the bottom. So what we'll do is set it to be minus 4.7. So it'll be in the exact same position at the bottom. And over here in our hierarchy, we don't want that to be just called wall top, so we'll call that wall bottom. So nice and simple, we have our two walls set up just the way we want to. So now we can actually start using them within our world. So the next thing to do is to go ahead and make some more objects, which will be our paddles for our players and the ball that we want to bounce around within the world. Okay, so now that we have our walls in place, let's go ahead and add the ball that we're going to use to fire around the world and two little paddles on either side. So as an example of how you can reuse assets, which is an important thing to learn how to do when you're making games, is reusing assets in different ways. Although this is obviously very simple, what we're going to do is use the same sprite that we use for our walls. I'm going to click and drag this in here. So this first little square is going to be our ball. So let's rename that to be the ball. Oh, we don't need a capital A in there. And we're going to click and drag another one in over to the side here. It doesn't need to be perfectly placed or anything yet. But this is going to be just called a paddle. So we have these two different objects now. Obviously our ball can remain this size because we want it to stay as a simple little shape. But our paddle, we want to make that a little bit bigger. So we're going to drag that up on the y-axis, which is the green one here. So I'm going to drag that up to be roughly that size. I'm going to make it a little bit wider as well. And I'm going to move this over so it's almost to the edges of the walls, but not quite. Just a little bit in like this, so that we'll have some space after the paddle, when the ball can fly past the paddle basically, and it can enter this area, and then we'll know that we've missed the ball and we lose a point. One of the problems at the moment though is that everything is white. So in the classic Pong, of course, the walls and everything were all white, and we had just the ball being white and the paddles being white. But we can make things a little bit more interesting, as it's not in mid-70s when we're making this game. So what we can do is, for example, on our ball over here, we're going to change the color of this just by clicking on color, and we're going to make this a nice white color. So we're going to make the hue over here be in the yellow range, and we're going to click and drag this so that it makes a nice yellow ball. And if we click off it, now we can see we've got this yellow ball here. We're going to grab our paddle and we're going to recolor this to be, we'll make that one red, like that. And we can see, I'll just move that so it's just nicely on this line kind of almost. I'm going to set the position of this to be at -8, just to be a nice flat number. And we're going to set the Y position to be at 0, like that. So now we have one paddle over here. We also obviously need to have a second paddle over here on the right. So we could just duplicate this and copy it over here. But the problem is, obviously we're going to apply various bits of control to this paddle. So we want it to be able to be moved around within the world. If we were to duplicate this now and put it over here, we'd have to, whenever we make any changes to this one, we'd have to manually go and make changes to the second paddle over here, which would be obviously very time consuming and something we don't really want to do. But what we can do instead is use things called prefabs which are a very, very handy thing to use within Unity. So if we go to our prefabs folder, now we've called this the prefabs folder. It doesn't actually matter what you call it. It only matters that what we're going to do now is drag this paddle into our prefabs folder here, and it creates a copy of it. And as I said, it doesn't matter that it's called the prefabs folder. That's just handily how we remember anything. But what it does is creates a copy of the paddle, and if we make any changes to this copy, which basically becomes the master copy of the paddle, if we make any changes to this, it'll apply to any paddles that exist within the world. So now that we created this, what we can do is click and drag it back into the world, and I'm going to pop this one down over here. And as an example of how this works, so say if I made a change to this original master paddle, what I could do is go to the color and say I could make it a nice color of blue, and you can see that instantly applies to these other two paddles that we have dropped into the world. I'm just going to undo that. If I go to this paddle here, I can make an individual change to this one, so I could make this paddle be blue, or kind of purplish almost. But you can see it doesn't apply to the other one, and it doesn't apply to this one down here. But what I can do then is make sure I have this one selected, and if I go to apply up here, like that, now it applies to all our paddle prefabs. So we can see if we click down on the paddle down here, it gets applied to that, so it's reflected down here. And now we have all of our objects being this kind of purpley color, and that's perfectly fine. But what we want to do to make sure that our paddles are kind of distinguished between them, I want to make sure that this is staying looking red. So what we can do to make sure that we don't just have these two paddles looking the exact same, I'm going to make this paddle over here on the right, I'm going to make it a nice color blue, and I'm not going to apply any changes to that one. But now back on this first paddle, when we make any other changes to this, so say for example, well, we won't say anything just yet, but what will happen is if we make any changes to this, anything that we change and then apply to the prefab will be copied over to our other little prefab paddle. But because we've changed the color on this, and you can see it's been changed because it's changed to this kind of bold color on the text here, the changes that we've applied to this one will be only reflected within this object. But if we make any changes to this one and then apply them as a prefab, they'll carry over to this other object, but they won't affect it. So say for example, I'm going to change this one to be, just for the moment, we'll make it green. I'm going to apply that change. Now our prefab is green, but our other object remains blue because specifically on this one within the world, we made that blue. So if I go back to our first paddle, I'm going to leave it at red just because there's something standard about gaming having red versus blue. We can apply that again. One thing we want to add, much like we added to our walls, is add a box collider to it. So I'm going to go to add component here again, and we can see we typed in box previously, so that's still saved in our search box, so we can just easily click on box collider 2D, and now we can see our paddle here has that little green outline around it. And if we hit apply now and we go over and look at the other paddle, we can see that that box collider has now been added to the other one, but still it hasn't lost its blue color. So those are the kind of basics of how prefabs work within Unity. They're very handy and very powerful and very, very useful on a daily basis within Unity. So the final thing we want to do is go to our ball here, and we want to give our ball a box collider as well so that we can interact with it. So now we have our ball can hit against other objects, so it can be able to hit against the walls, and it'll be able to hit against the paddles on either side. But of course, at the moment, it's not doing anything. If we hit play in our game, all that happens is our 5 little objects here just kind of stay exactly where they are. So let's start adding some actual physics into the game. One of the very handy things about Unity is that it comes with a built-in physics system that we can take advantage of for working in our own games. So to use it, we're going to go to our ball here. I'm going to switch back to our scene view. I'm going to zoom in on the ball just so we can see it a little bit better. And what we're going to do is apply a rigid body component to it. So I'm going to start typing in our search box, rigid body. So we got rigid body and rigid body 2D. And because we know we're working in 2D, we know we want to apply a 2D rigid body to it. So basically what this does is make this object be able to move around within the world. So if I was to now go to the game view and hit play, we'll see our ball will drop down and it'll hit against a wall. But of course at the moment all it's doing is falling down and hitting against the wall and staying there. So let's make it so that our ball will actually bounce off the wall. To do that, what we're going to do is go to our materials folder here, and we're going to right click and we're going to create a new physics material 2D down here, and we're going to call this, we'll just call this bouncy to keep it nice and simple. And all this will do is make it so that our ball will be able to bounce. So we're going to set it so that our friction will be 0 and our bounciness, we'll set that to be 1. I think should be absolutely fine. And that'll just mean that our ball will bounce as high as where it starts off. Roughly speaking, it can be a little bit of a slight quirk within Unity, but we'll see it now in action. And the way we can apply this to our ball is if we go to our ball in our hierarchy here, we can see on our box collider there's a slot for material here. So I'm going to click and drag our bouncy into our material slot there, and then if we hit play, we'll see that our ball will start to bounce just like that. So there we go, we got our ball kind of bouncing around. You can see it's actually bouncing just a little bit higher than where it starts off with, which is actually kind of handy for our game, because what it'll mean is that our ball will start to speed up a little bit as it bounces. But if you want it to bounce exactly where it is, I think it's around 0.97, I believe, should get you relatively close to getting it bounced to exactly where it was. You can see that's just a slightly bit too low actually, but it's just a matter of kind of tweaking it around to see how you feel about it. But we're going to stick with 0 and 1 for our friction and bounciness. So now that we have our ball bouncing off the ground, or sorry, bouncing off the wall like that, we can see it's working. But of course, when we actually want to play our game, we don't want this ball just hitting against this wall here constantly and trying to basically bounce here. Even if it's bouncing against our paddles, then what we'll find is our ball will just be kind of bouncing along like this, which isn't what we want. What we want it to be is kind of like more like classical Pong and more kind of like tennis, although tennis doesn't really have walls at the side. But we want our ball to be, say, flying off this guy and going bounce, 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 and then behind the other person. So we need to make sure that our ball isn't falling down, and the way we do that is by going to our ball and then going to our rigid body and set the gravity scale to be 0. So now if we hit play, we'll see that our ball isn't being affected by gravity anymore, but that's absolutely fine. It's not moving around, but we know that we've now applied physics to it so that it will bounce off the walls whenever it does actually get some movement applied to it. So the next thing we're going to do is look at how can we actually get the ball moving within the world. Okay, so now that our ball is bouncing off the walls, we need to actually start it moving properly within our game. And to do that, we're going to create a simple script that will get our ball moving once the game starts. So we'll go into our scripts folder and we're going to create a new script. So we're going to go create C# script, and we're going to call this script ball controller. So as created, we're going to double click on it and it'll open up in MonoDevelop by default. And of course, you may be someone who has set up Microsoft Visual Studio is another good option for editing within Unity, but we're going to stick with the default system, which is MonoDevelop, and use that to demonstrate everything as we go through. So once MonoDevelop loads up, we'll be given this kind of default script file that Unity has. So just in case you've never encountered any kind of coding like this at all, and specifically coding within Unity, we're given these two different elements here that we can use within our game by default. So these are our start function and our update function. And our start function and update are, as these little bits of description here state, our start function is used as soon as our game starts, or B, as soon as an object comes into the world. So say in the middle of the game you brought a bullet into the game, for example, the start function that would apply to that bullet would only happen at the moment when it's brought into the world. So those are the two times that our start applies. And then the other default thing we have is our update, and our update is applied every instant of the game. So say you have a game that's running at 60 frames a second, for example. Your update that is being referred to here would be called 60 times during that second. So we'd have this running the whole time, and this is where the bulk of your action will happen with any particular game. So whenever you need anything to happen within Unity, generally speaking, most of the time it'll happen within the update loop. So if you have any timers counting down, or any regular actions, or if you're taking any input from the player or anything like that, that'll all happen within the update loop here. So we're specifically wanting to control our ball. So what we want to do is make it start moving as soon as the game starts playing. So we'll obviously need to start doing something within our start function here. But to be able to start moving it, we need to know how fast it should move, and we also need to know what's making it move. So back in our game here, we know if we click on the ball, the thing that's controlling our ball being able to move around within the world is the rigid body, and that's what gives us its velocity, and it's what applies the physics of Unity to the ball. Now obviously our box collider is what's making it solid, but all that does is tell Unity, okay, this box collider, say, is touching against this box collider, so now the physics should do something. So to be able to work out what it should do, we have our rigid body doing that. So what we need to do is we need to know what the rigid body is, and then we need to know how fast our object should be moving. So to know how fast our object should be moving, what we're going to do, above our start function here in this little gap, but below where we have public class ball controller mono behavior, so inside this set of curly brackets we have one opening bracket here and one close one down here. Just above all of that, we're just going to say here public float start force. So what are all these things here we just created? Again, if you've never encountered any kind of coding like this at all, it might be a bit confusing at first, but you'll see it's all made of very, very simple building blocks that add up together to make your games simpler than you would think they could possibly be, really. So we have at the start here, we have public. Public all public means is that we'll be able to interact with this thing that we're creating here back within Unity. So over here, for example, in our rigid body, we can see here there's a mass of 1 and a linear drag of 0. And the reason we're able to change these values at all is because they're set up as public. The other option is to set it as private. So a private float start force would mean that it wouldn't appear here in Unity and we wouldn't be able to interact with it. So we want to make sure that we set anything that we want to be able to set. So for example, we know that we want to be able to set how much force our object will have to start off with. We know we want to be able to set that within Unity. So that's why we make it public. So next thing we have is float. And float is basically a number value. So there's two basic types of number values within Unity. There's floats and there is ints. So what's the difference between them? Very simply and very straightforwardly, an int value here refers to integer, and what it is any kind of whole number. So it can be 0, 1, 2, 3, 4, 5. It could be a million, it could be a billion. But the important thing is it doesn't have any decimal places within it. Whereas a float value can have decimal places. So it could be 1.3, it could be 2.4756, whatever. It could be a billion.3, whatever you want. But the point is that an int value can only be a whole number, and a float number can be any number that has a decimal point within it. So that's our first two bits dealt with here. And then finally we have this bit, start force. And start force is just the name that we're giving this float that we're creating. So we're creating a public float. So what we're saying is, okay, we need to have a number that we can use that has a number that we can use that has a decimal place within it, and we're going to refer to it as start force. So if I was to save this now and go back into Unity, we're going to apply this script to our ball before we do anything else, before we go any further really. You need to it's gone now, but we'll see it again, I'm sure, is when we save a script in MonoDevelop here, when we go back to Unity, what you'll see is a little circle spinning in the corner here, and that means the script is compiling, and once it finishes compiling, we'll be able to do stuff with it. So we'll come across that again very soon. But if we go to our ball here, we want to apply the script that we've created to it. So there's two ways to do it. We can go to add component and we could start typing in our ball controller script, and you'll see it pops up in the list here. Or what we can do is just click and drag. So we'll grab our script here and drag it over to add component, and just below it we'll drop it in there, and now we have our ball controller script there that we can interact with. And we'll see that the object we created, or sorry, the number we created back over here, our start force, you can see in our script here, we now have a start force value. So if we want to give this a number, say we'll give it a start force of 5, I think will be useful. At the moment it won't actually do anything, of course, because we haven't applied that in any way. We've just said, okay, here's a number that we're calling start force, and we can now interact with it here because we made it public within Unity. So if we go back to the script, just to clear up one little thing as well, over here we've created the value and we made it with a small letter to start with and then a big capital F in the middle of it. But if we look back in Unity, we'll see we have start force here, we have a capital S at the start now, and we also have a space in the middle of it, which we didn't write in when we created the name. So you might be thinking, oh, maybe is start force like something that Unity would understand automatically? It isn't. It's simply the way we write variables, which is what this is now. It's a variable that we've created, and it's the way we write them within Unity. And it's kind of the common kind of way these things are written within coding, is to always start the word with a small letter, and anytime you want a new word starting, you make it a capital letter. So if I was to say start force number, for example, if I'm to save this now, go back into Unity, we'll see this little compiling, little kind of loading symbol or whatever you want to call it. And what we'll see now is it creates a space and then it says number. So basically any capital letter that you use here, it'll create a space before it within Unity, just to make it more easy to read for us as we go through. I'm going to delete that number there like that. So now we have our number value start force and we know how it applies to our game here. But if we want to actually make our script move, what we need to do is apply it to our rigid body. So our rigid body is what makes it move within the world. And if we want to make any changes to the rigid body, we need to know what that rigid body is. So we need to create a reference to it in our script here. So what we're going to do is, unlike it being public, we don't need this one to be public. We're actually going to set this to be a private. We know we need to interact with the thing which is the rigid body 2D. So that's our rigid body 2D there. And we need to create a name that we're going to use for this variable that we're creating. So we're going to say, we're just going to call this my rigid body. Nice and simple. And all this does is creates an empty variable on our script, which is of the type rigid body 2D. So we've basically created on this script here, we've created an empty rigid body 2D. We made it private so we can't actually see it back in Unity here. If we let it compile, it'll compile away, and once it's finished, we won't visually see any changes here in our ball controller script. But there is a way to be able to see them, and it's a very simple thing and a very handy thing actually as well. If we go to these three little lines here, we've got some options we can use for our inspector, and we can hit debug here like this. And when we switch to debug view, that basically it changes how we view all the objects within the world. You can see we get some different options for our rigid body and for our sprite render and stuff like that. But what it also does is makes any private variables visible. So now we can see that my rigid body here is now visible, and of course it's empty because we haven't put any values into it at all. So we've got my rigid body and it has none because there's no rigid body applied to it. So I'm going to switch this back to be the normal view because we don't really want to stay in debug view the whole time. And we're going to go back into our ball controller script. And now that we have our rigid body, an empty kind of reference to it, we need to know specifically which rigid body we want this to be talking about. So what we want it to be talking about is the same rigid body that's attached to our ball object within the world. So we have our ball controller script attached to it, and we also have the rigid body. So then what we can tell Unity, we can say my rigid body, which is the variable we just created up here, we can say that should be equal to, we'll use a function here called getComponent, and then we use a sharp bracket, and we say rigid body 2D, like that. And then we put two normal brackets at the end, and then we hit semicolon at the end of the line like that. So what is this sentence doing? So what we're doing here is saying, okay, the my rigid body, which is the empty variable we just created up here, what we want to do is set that to be the component that's already attached to the ball. So we know that this ball controller script is attached to our ball. So what we can say is get the component that is also attached to our ball that is of the type rigid body 2D. So it'll find the rigid body 2D that's applied to it, and it'll set that to be equal to this empty rigid body here. So this will be happening within the start function. So what we can do is check how this works in Unity. And it's important whenever you write any kind of code to make sure that it works as you're going through it. So don't ever write like 100 lines of code and then go back into Unity and then something small has gone wrong and you don't know what it is. It's important to, as you write code, test it constantly to make sure that it's all working. So if I go back into the game here, again, we can't see our rigid body in our ball controller script, so we're going to switch to the debug view once it's finished compiling. So we're going to go debug here, scroll down, and we'll see at the moment it's empty, but if we hit play, then as soon as the game starts, it'll read from the start function and it'll go, okay, set it to be the rigid body that's applied. So you can see it says ball here. That's because it's getting the rigid body 2D that's on the ball. So perfect, that's exactly what we wanted to do. And then the final thing we want to do is apply some force to make it move within the game. So what we're going to do is go onto the next line here, and we're going to say on my rigid body, what we want to do is say dot velocity. So what this means is we want to access the velocity of the rigid body, and we're going to set it to be a new value. So we're going to set it to be equal to a thing called a new vector2. So a vector2 is basically just an object with two numbers. It's got an x value and a y value. So because we're dealing with 2D, everything is only going to move on the x and the y axis. It won't be disappearing into the background at all. We're not worried about that. It's only moving either left and right on the x axis or up and down on the y axis. So on our vector2, what we're going to set this is to, by default, apply on the x axis. We want to give it the start force that we're going to apply to it. So we're going to say on the x axis we want it to be start force. So say if we had it be 5, we're going to say, okay, the velocity of our object when we start the game on the x-axis should be 5, so it'll be moving at a speed of 5 to the right. And on the y-axis, we're going to do the exact same and give it the start force as well, because it might as well be moving up and to the right when we start the game. So we're going to now save this. Before we go back into Unity, there's one more little thing we need to be aware of whenever we're creating scripts, and that's to make sure that any line that we create where something happens, so say for example on this line we've set our rigid body, my rigid body variable to specifically be the rigid body component. At the end of that line we need to make sure and put a semicolon at the end of the line. If you forget a semicolon, basically the script won't know what to do and it won't run in the game. And forgetting semicolons is probably the most common coding error that anybody does, and you are guaranteed to do it when you're making a game. It's one of those things that everyone forgets about sometimes when you're coding away, but it's a very simple thing to fix and a very simple thing to create. So basically, if you get an error within Unity, your first question should be, did I leave a semicolon out somewhere? So it's important to remember at the end of any line where you're making something happen, you put a semicolon in. So on these lines we're making something happen here, but on these ones up here, for example, the thing we're making happen is that we're creating an object within the game. So it's important to remember always to put your semicolons in place. So now that we've applied our forces to our rigid body, let's go back into the game here. Let that compile down in the bottom corner there, and then I'm going to switch this back to the normal view. I'm going to set our start force to be 5 like we had before. It got reset because I was changing the name of the variable. That's another actually important thing to remember. If you change the name of a variable, it will lose whatever value you've given it. So when I changed this to be start force number, it reset it back to be 0, and then when I set it back to be start force, it still remained at 0. But now we've set it to be 5, so let's hit play, and what we should see is our ball fly up in this direction and bounce off the wall. There you go, we got our ball bouncing just the way we wanted to. I'm going to just move it over to the side here just so we can get a little bit more action out of it than just bouncing off the wall once. But you'll see now that we've applied a force that will start our game, and we've also got it bouncing off the walls just the way it should be. So there you go, we've got our ball moving just the way we want. So let's start making it so that we can move our paddles up and down, actually start interacting with what the ball is doing.